Here are the solutions to homework set number 13 for ECE 341. This homework set looks at t-tests with two populations. Now, the first set of problems look at two people playing a game. Player X rolls 4 10-sided dice. Player Y rolls 5 10-sided dice. Whoever has the highest score wins. X wins on ties. So let's find the probability that X wins. One way to do that is a Monte Carlo run. I'll roll the dice 100,000 times and count how many times X wins. Now if I do that just one time, X wins 28,381, so a 28.3% chance. The problem with the single run is I don't really know, give or take, what the confidence interval is. So technically what you should do is run at least 2 trials. I ran 10 trials. Once I have 10 trials, I can find the mean, find the standard deviation. In this case, I want to find the population's average. So I do divide by the square root of n for the standard deviation. That tells me that the actual odds of X winning is somewhere between 28.29% and 28.42%, with a probability of 0.9. So that's the actual number I'm looking at. Now, to do that, I actually roll the dice 1 million times. Can I get basically the same answer in fewer die rolls? The answer is, of course, yes, but that takes some statistics. Suppose I just roll the dice 4 times. Can I estimate the probability that X wins rolling the dice 4 times? Well, sure. What I do is roll the dice 4 times. I get a mean standard deviation for X and Y. Create a new variable W. That's the difference in the means. So there's the mean of W, the standard deviation of W. Here I add the variances rather than subtract. And I don't divide by the sample size because, again, this is just for a single run. I want to find out for a single run, let's say the mean is minus 9.75, how far it is from 0 in terms of standard deviations. So over here, this is where X beats Y. This is where X loses to Y. I want to find this area for any given roll. That's an individual. So when I do that, it has a t-score of 1.1. That's the distance from the mean in terms of standard deviations. Convert that to a probability, it's 17%. The true answer from Monte Carlo with a million die rolls was 28.29%. So it's a little bit off, but it only took 4 die rolls. If I increase the sample size, I get better answers. Increasing the number of rolls to 20, I've got a mean for X, mean for Y, create a new variable W, the difference in the two. How far is the mean from 0 in terms of standard deviations? It's 0.46. Convert that to a probability. Now with 19 degrees of freedom, sample size of 20, there's a 32% chance that X wins. Again, closer to 20%, the correct answer. Repeat with 100 die rolls, and you get 25%. So here's kind of what you get. With the Monte Carlo, if I roll the dice 100,000 times, I kind of know what the odds are, 28.29. If I roll the dice a million times, I know the confidence interval. With a t-test, I can do it in a smaller number of rolls. With 4 rolls, 20 rolls, 100 rolls, as I get more and more rolls, I get more and more accurate. And technically what I should do is repeat this a couple times. That'll give me the confidence interval. So that was problem number 1 through 4. Problem 5 is go to this website, and what it does is it checks your reflex time. So you click a button, the light turns green or red, you hit the button when it turns red, measures your reflex time. So doing that, I got 4 measurements. A day later, I took the same measurement. Is there a difference? Was my reaction time better on May 1st than it was on April 30th? Well, to do that, I've got 2 populations. Create a new variable W. That's the difference between the two. The mean of W is the mean of A minus mean of B. The variance of W is the sum of the variances of A and B. Take the square root, I get the standard deviation of W. The t-score is then the ratio. So again, this is what W looks like, A minus B. The mean is 17. So 0 is over here. This is A's bigger than B. How far is 17 from 0 in terms of standard deviations? It's actually 1.69 standard deviations away. That's your t-score. Converting that to a probability is going to StatTrack. 1.69 standard deviations means the tail is 8%. So there's an 8% chance that A will have a lower reaction time than B next time around the experiment. That's for an individual. If I do a population, saying what's the chance that my reflex time is getting worse? Population B versus population A. Since that's a population, I divide the variance by the sample size. Means that there's now a 1% tail. So 1% chance that A was overall faster than B. So it kind of depends upon whether you're talking about individuals or populations. Second test. The aim trainer is you click on this link and it has a little target. You move the mouse over to it and click it. Target moves. Move the mouse over to it and click it. Repeat 30 times. How many times, or what is the average time to acquire the target? So with my dominant hand, there's my first measurement, repeat, second measurement. Do something different. I use my dominant or non-dominant hand, my left hand, first measurement, second measurement. What's the probability that my right hand is faster than my left hand? So to do that, I take my data, find the mean, standard deviation, find the t-score, create a new variable W, the difference between the two, find the t-score, convert that to a probability, and it's 44%. So that says there's a 44% chance that my dominant hand's reaction time is less than my non-dominant hand, which is kind of odd, but that's what the data says. In terms of populations, if I want to say, well, this is for individual. Next time around the experiment, who's going to win? Population. Which hand is better overall? So which one hand should I be using when I'm playing video games? Well, from the data, I divide the variance by the sample size, take the square root to get the standard deviation, find the t-score. So this says my dominant hand is better than my non-dominant hand with a probability of 41%. So according to this, I should be using my non-dominant hand. I don't believe it, but this is a sample size of 2. You can get things with a small sample size. If I had a bigger sample size, I think my dominant hand would beat my non-dominant hand. But that's what the data says. So that is some homework set number 13, using t-tests to compare two populations.